Welcome to the today's session, students. Today we are learning about the structures in C. As we all know, in our real life, whenever we talk about any of the item that is present, it need not be described by a single data type. Example, if I take an example of a student, now the student is a combination of his roll number, name, to which course he has or she has enrolled to, and how much fees they have paid. Right now, when I want to describe a item student, it is not necessary that all the attributes, means the properties which are describing the student, will belong to the same data type. If I take the example of a roll number, it becomes an integer, the name will be a string, address of student will be the string, the course he has enrolled is a string, and the fees he has paid or she has paid is a floating value. Right now, C provides us to store such a information which is a combination of different data types under one name called as structures. That's why structure is a user defined data type which is capable of storing the related information and whose information can belong to the different data type. Okay, the definition goes like this: the structure is a user defined data type that can store the related information. What were the related information? With one student, the roll number, name, address, the course are related to each other, right? I am storing them together. It is similar to the records that can be used to store the information about an entity. Here I have taken the entity as a student, right? So, in the previous classes, we have also learned the concept of arrays, which was also containing the different elements. But the major difference between the structure and the array is, in the array, I was just storing the information which belong to the same data type, right? Roll numbers of all the students. Everything which belongs to the roll number was an integer. So, array of roll number will have only the data type which belong to the data type integer there. But whereas in the structures, I can have the elements which belong to different data types. One more thing. In the structure, each and every element has its own individual name with which we can refer it. But in the array, we are accessing the individual element with the help of the index or the subscript. Let us take how we can declare the array now. To declare the array, we are using the keyword struct. Struct is a built-in keyword which is used to declare the structures. Struct followed by structure name, and what all the members you want to be the part of this structure should be defined with their own data type and the variable name. Their own data type and the variable name. There can be n such of elements can be present within the structure. If I compare it with an array here, how I used to declare the array? One data type followed by the name of the array followed by its size, right? Since everything belongs to the same data type, I was defining the data type only once here, right? But individual elements that are present in the structure will have their own data type. That's why for each and every variable, I need an individual separate name and its data type. Name and its data type. Let us take example here. Struct is a keyword. Structure name is student here. Student structure has the data members as roll number, data type is integer, name is a string of length 20 characters, course is again the string with the length 20 character, and fees the student has paid is a floating point value. Remember, whenever I declare the structure like this, right, whenever I declare a structure like this, no memory is allocated till this time. Only a template is given to the compiler saying that my structure will look like this. It is as good as you are drawing the blueprint of your house on a A4 size paper. It need not require actual land of 30 by 40 site to build that particular building. I am just having a blueprint of my building structure. It is the same way. The memory is not required. I will just say if it is to be used, the structure has to be like this only. It should have a bedroom, it should have a door, it should have a window. Here I say it should have a roll number, it should have a name, course and fees. It is just a template. Remember, when the structure is declared, no allocation of the memory is made there. Until I have a variable of type structure, no memory is allocated. Now let us see how can I declare the variable of structure now, right? So struct is a keyword, name of the structure followed by the variable name. So when this particular statement is executed, actual memory is allocated to the variable stud1, which belongs to the data type student, which is a structure. There are two ways of declaring the variables. One is, as I said, structure name and the variable name. Otherwise, while you are declaring the structure only, you can pass the variable names here only, right? So I have defined a structure and I said these are the content of the structure, and I said these are the variable 1 and variable 2 of the structure here, right? There are two ways. One is I can define the structure, declare the structure separately, and I can have the variables. Otherwise, along with the declaration only, I can tell there are two variables which belong to the type student. So when this particular variables are created in the memory, allocation is made to store all the variables which are present in the structure. What are the variables that are present in the structure? We had roll number, we had name, we had course name and the fees, right? 2 byte within the student is reserved for storing the integer value, which is a roll number, and 20 bytes are reserved to store the name and the course. Next is 4 bytes are reserved to store the information with respect to the fees. Similarly, student 2 will have its own memory location allocated to store its roll number, its name, course and the fees. Next one is, how can I initialize the structures now? Right, previously we used to define the variable like int x, then I would say x is equal to 10. Means I have initialized a variable x with the value 10 here. Now, how can I initialize the structure now? Because structure itself has many more variables within it. So there are two ways to initialize the structure. One is, whenever you declare the structure, right, followed by the variable name, here only I can pass the values to the data members of the structure, right? Constant 1 will give the value to the variable 1, constant 2 will give the value to the data member 2, and constant 3 will give the value to the data member 3, and so on. This is the first way. Second way is, you can declare the structure separately, and when you are creating a variable of structure, you can pass the values here, right? The structure is declaration ends here, the structure declaration ends here, followed by variable we are declaring. When I was declaring the variable, that time only I will pass the value to the variable. We see them with example. I have a structure student. Student has roll number, name, course and fees, right? So when the structure declaration is over here, it is followed by the name of the structure variable, Here only I am passing the values within the flower braces. Roll number will take 01, name will take Rahul, course will be BCA, and the fees paid is 45,000. This is the one way. Second way is what? I have declared the student structure. In the second line, I will be explaining about the variable name. Once the variable name is declared, here I am passing the values to the members of the structure, that is roll number, name, course and fees. These are the two ways of initializing the content of the structure. Next one, when actually the data will be stored into the structure member variables, they are stored in a sequence. Look here, student 1's roll number is 01, his name is Rahul, he is enrolled to the course BCA and has paid 45,000, right? So continuously in the memory, 2 bytes is reserved for roll number, 20 bytes for name, 20 bytes to store the name of the course, followed by 4 bytes to store the information about the fees that particular student has paid. If in case you do the partial initialization, means you are not sure which course he has enrolled to, right? You just know the roll number of Rahul is 7 and you don't know which course he has enrolled and how much fees he has made, right? That time automatically by default null value will be set for a string and 0 will be set to the floating value, right? Since it is a floating value, decimal point will be there, so 0 will be stored as 0.0. This is called as partial initialization. Next one is, we have created the structure. Now we have declared what are the values that are present in the structure. Now how can I access them individually, right? So we know the dot operator is used to access the content of the structure. So whenever I am using the dot operator, structure name followed by the dot operator and which data member you want to access. I say from the student 1 dot I want to access the roll number. Student 1 dot roll number is equal to 01. I say student 1 dot name is equal to Rahul. I am accessing the individual data members. If you look here, at once the data was stored here. Roll number 1 Rahul BCA 45,000 is assigned here. But if you want to allocate them by accessing the individual data members, then you should take the help of the dot operator. Dot operator is preceded by the name of the structure variable. Here structure variable name is student 1. To access the name, I say student 1 dot name. To access the course, I say student 1 dot course. To access the fees, I say student 1 dot fees. Similarly, to print them, what is required? Printf percentage yes student 1 dot course, means the content from student 1's course will be accessed. Why it is required? Because look here, in the memory we have student 1's information present here, student 2's information. Now you should distinguish between this roll number and this roll number, right? This roll number belongs to student 1, this roll number belongs to student 2, right? That's why it is necessary that you take the help of dot operator along with the name of the structure variable to access individual data members of a structure. Next one is comparing and copying the content of the data structure. Assume that I have a information about some particular structure. Same thing has to be copied with the second row. That time what I can do? I can say structure 1 is equal to structure 2, right? So what happens if I say structure 1 is equal to structure 2? The content of 1 will be copied as it is to the structure 2. It is as good as I have explained, created a variable x is equal to 0 and I say y is equal to x. What is the meaning of y is equal to x? Content of y will be same as the content of x. So y also will have 0 in it, right, because x has 0. The same way, look here, student 1 has which all information? Student 1 has information, roll number, name, course and fees there. Roll number is 1, name is Rahul, course BCA, fees paid is 45,000. And I have one more variable, student 2, right. So what I will do, student 2 is equal to student 1. I already have the data for student 1 as it is the copy to the student 2's information. When this statement is executed, student 2 dot roll number will be again 01, student 2 dot name is equal to Rahul, student 2 dot course BCA, student 2 dot fees equal to 45,000 as it is copied from student 1 to student 2. Next one is, whenever we want to compare the structure variables, directly I cannot compare student 1 greater than student 2, right. Entire one structure cannot be compared with entire another structure, but the data members can be compared. Look here, student 1's fees greater than student 2's fees, right. Student 1's fees is compared with student 2's fees. Individual members can be compared, but you cannot compare the entire one structure with the another structure. Next one is, how can I find out the size of a structure now, right. So if you look at the area, memory area that is allocated to the structure, in the previous slides I said memory is separately allocated for roll number, it was allocated for the name, it is allocated for the course and it is allocated for the fees, right. So one structure will have how many parts here? 1, 2, 3, 4. The combination of the area or the memory consumed by individual will be added up to get to know the entire size of the structure. Okay. So let us see with this example. I have a structure employee. The properties which are describing employee are, the data members of the structure employee are employee's ID number, employee's name, employee's salary, the designation of the employee and the experience of the employee are the data members of the structure employee here. Look here, EMP is a integer, that's why it is taking 2 bytes of memory. Character array name, since it is length is 20 bytes, 1 character takes 1 byte, 20 characters will take 20 byte of memory, that's why plus 20. Next is double, salary is stored with a higher precision since it is double, right. So it requires 8 byte of memory, right. The next one is designation. To store the designation, it is a string with the length 20, so it is taking 20 byte of information. Next one, experience belongs to the data type float. Float will consume 4 byte of memory location, that's why. So altogether the size required to store the structure employee is what? 22 plus 8 30, 30 plus 20 50 plus 4 54. 54 bytes is required to store the structure EMP, right. Two ways are there to calculate the size of a structure. One is you can add up the individual data members memory location and give the size. Another one, you have a built-in size of operator can be used. For example, I can say, instead of calculating the size separately, if I say EMP is a structure name, E is a variable of type structure. So I have declared a structure variable here, struct EMP E. If I say size of E, it automatically gives me the answer as 54 by calculating itself. There are two ways. Next one is nested structures. As we all know, nest means something is within another one. We are telling here nested structure, that is one structure is present inside the another structure. Look here, the structure one starts from here to here. Within that one, I have one more structure here. This structure is nested within this bigger outer structure here. This is structure nested within another structure. Example, I want to store the information of the student along with his or her roll number, name. I want to store the address information also. But I know if I give the address as a continuously 100 byte information, I may be continuously storing the data. Instead of that one, what I felt is, as a programmer, I thought, let me split my address into again some piece of information, that is house name, house number and the pin code of the area, right? So it itself is a structure and this is present as a part of one more structure, right? Look here, another way is what? I can have one structure, I can have another structure. Look here, what is present in this structure? Instead of storing the name continuously, including the first name and the second name and the surname, what I felt is, as a programmer, I thought, let me split the name into three parts: first name, middle name and last name. I club them as one structure with the name, and instead of storing the date of birth continuously as one of the string, I felt that let me divide the date of birth into three parts as date, month and year. Now there are two structures. One is a name which consists of 3 character arrays. Another one is I have a structure date which has 3 parts which belong to the integer values. Now I define the data type student. In that one, I have a variable which belongs to one structure, another is a structure, like so. It is also within one structure I have two more structures. It is also called as a nested structure. There are two ways to nest the structures. Next one is, how can I access the content of nested structures now? Look here, to access one content, I was using the dot operator with the structure name. Now one structure is present within another structure. It has its own name, right? There will be two ways, two times I will be using the dot operator. To access the date of birth of a student 1, what I will do? Student 1's date of birth. Within the date of birth, I am accessing the date. Student 1's date of birth, I am accessing the month. From the student 1's date of birth, I am accessing the year here. So how am I accessing the data? The variable is student 1. Within the student 1, I want to access the date of birth. Within the date of birth, I want to access the date here. That's why what is required? First I need to know which student's date of birth I want to check. That will be student 1. Within the student 1, what I am accessing? I am accessing the date of birth structure. Within the date of birth, what thing I am accessing? I am accessing the date. Right? So two times I will be using the dot operator. Next one is, can I have arrays of structure? Yes. because the arrays of structure will help me to store the information with respect to n number of students continuously into the memory. So as we all know, whenever we are declaring the arrays, what is required? Data type, name of the array followed by the square bracket, a size has to be mentioned. So what is the meaning of this statement? X is an array of integers, right? So X is a array of integers. So here I want to create the array of structures. That's why I need to use keyword struct followed by the structure name followed by the size. So student is name of the structure. Stud30 will enable me to store the information about 30 students. Will help me to store the information about the 30 students. Look here, one student's size is what? 2 plus 20 plus 20 plus 4, right? Because int is take 2 bytes, string of 20 characters are taking 20 bytes, float will take 4 bytes. That's why 46 is the size of one structure variable, right? So in the memory, when I create array of 30 such students continuously, 46 bytes like this, 30 students information will be continuously stored. Within this part, again I will be having roll number, name, course, fees. Roll number, name, course and fees, right? This will be stored as one chunk. This is student 1, this is student 2. Like that we have student 30, right? As we all know, to access the content of the arrays, indexing is required. So they will be passed as the index here. They will be passed as index. So whenever we want to work with the index, obviously we take the help of looping statements and we mention student of ith roll number. If I want to enter the information about the 5th student. So what I will do, indexing will start from 0th location, right? So if I am starting the indexing from 0, the 5th student will be present as the index 4. 0, 1, 2, 3, 4, right? 5th student's information is present at the index 4. So students 4, roll number is 9, name is Rashi, she is enrolled in MCA course by paying the fees 60,000. This is how we assign the value to the structure arrays. One more way is there, if we have less number of structure variables in the array, we can give the data within a single statement. Look here, I need to store the information about the 3 students, right? So what I can do, in one flower brace, I can pass the information for one student, right? This belongs to student number 1. This belongs to student 2 and this belongs to student 3. This is stud of 0. This is stud 1. This is stud 2. Like this I can store the information. Look here, stud 0 dot roll number will fetch me 01. Stud1 dot name will fetch me RN. Stud2 dot fees will fetch me 45,000. Right? This is how we can work with the arrays of structures. Next one is, whenever we are working with the structure, we may need to pass the entire structure to the function so that we can work upon it. That is, I want to know the average marks scored in a particular class. Right? What am I interested in? I will pass the student marks to the function and I will calculate the sum first divided by number of students, which will give me the average marks of a particular class there. Now, so whenever we want to pass the structures to the function, there are two ways. Either I can pass the individual members or I can pass the entire structure to the function, right? Look at this particular example. We have a structure whose name is point. It has two data members, x and y. So, a point is a structure which has two parts, int x and int y. Okay. Now, I have a function called as display, which is used to display the coordinate of a particular point. Now, there are two ways to display the coordinator of a particular point. One is I can pass these x and y separately, I can print them. Otherwise, I can pass this entire structure to the function and I can print them. We will learn them one by one. In this example, I will explain you how to pass individual member variables to the function. Okay, this is a structure point. It has two data members, x and y. The template of this is point is, it is capable of taking two integer values. The size of the structure is 4 bytes. Okay, display is a user defined function which returns nothing. Void means which returns nothing but accepts two int values. Which accepts two int values. Look here, I want to pass the individual elements of the structure here. Each element is a int value. Yes, I can pass them. Okay. In the main, what I have done, I have created a variable of type structure. Point is a structure. P1 is a variable of structure. It is initialized with 2 and 3. So, in the memory, which is pointed by the pointer, which is referenced by the name of the structure, P1 will have two values, 2 and 3, that is x will have 2, y will have 3. I am passing the individual members, that's why individual members are accessed with the dot operator. P1.x and P1.y will be passed to the function when it is called. So, whenever the function is called, the control will be passed to the location where it is actually written. Okay. P1.x has 2, P2.x has P1.x has 2, P1.y has 3. Now, these two will be accepted as a and y, and I am printing the value of a and b. P1.x is received at x, P1.y will be received at the variable b there. This is how we can pass the individual members to the function. Next one is, I can pass the entire structure itself. Without splitting them, I am passing the whole structure. That's why, let us take the same example again here. This is a structure declaration which is saying that template to store the point is, it has two members, both of them belong to the same data type int, their names are x and y. Here function name is there with the display, it is accepting the entire structure. That's why we are used the name of the structure as point here. In the previously we have accessed them separately, right? So, it was accepting int and int. Here it is capable of accepting the entire structure. That's why the data type that the function can receive is the name of the structure. Okay. So, in the main, P1 is a variable of structure point. It has initialized with the values 2 and 3 for x and y respectively. So, when I am calling the function here, P1 is passed to the function when it is called. In the previous example, we had passed P1.x and P1.y separately because we were accessing the individual members. In this function, in this example, we are working with the entire structure. That's why the whole P1 is passed, not the individual values. Okay, so when this function is called, the control will go to the location where it is accepting the entire structure itself. So P will have the content of P1, right? So when I print the P1 dot x and P2 dot P1 dot y, I will be accessing the content as 2 and 3.